Okay, once you know the definition of relative atomic mass and relative molecular mass, now it's time to use those definitions to calculate the relative molecular mass for more molecules. So I'll show you how to do it. I'll do it in different molecules. First, I'll do it in ionic molecules, then I'll do it with some covalent molecules. So let's start with ionic molecules or ionic crystals or compound. So I'll start with ionic molecules. For example, like NaCl, okay, and NaCl is so relative molecular mass of NaCl. We look at how many Na atoms are there. So there is one Na atom. So relative atomic mass of Na plus relative atomic mass of Cl. And Na is 23 plus Cl is 35.5. Refer back to the periodic table and you'll get 58.5. This is relative molecular mass of NaCl. Okay. Another example, like this was the simple example. Now we'll talk about salts. For example, like Na2CO3, sodium carbonate. So we're going to calculate the relative molecular mass of Na2CO3, sodium carbonate. So Mr Na2CO3. First, what we need to do, we need to find out how many Na atoms, how many carbon atoms, how many oxygen atoms. So to find out the number of atoms of each element, we need to look at the subscript. Before we looking at the subscript, we need to find out how many elements are there in the molecule. And so I'm going to circle each type of element in it. So this is one is sodium element present in it, another is carbon, and the last element is oxygen. So there are three elements in it. We have Na, and we have carbon, and we have oxygen. Once you identify the type of element, then you look at the number of elements or number of atoms of those elements present in the molecule. To identify, we'll look at the subscript. So Na, there are two Na atoms. There is one carbon, you don't need to write one, and there are three oxygen atoms. And then 2Ar Na plus ArC plus 3Ar oxygen. And then you use the periodic table, put the atomic masses, relative atomic masses, to calculate the relative molecular mass. Na is 23, carbon is 12, 3 times 16. So it's 46 plus 12 plus 48. So it comes 106. So relative molecular mass of sodium carbonate is 106. Or you can say the molecular mass of sodium carbonate, is 106 gram per mole. Now we look at the double salt with crystalline water in it. Okay. I will show you the same molecule. So this is anhydrous salt, Na2CO3. This is anhydrous because there is no water. Anhydrous salt because there is no water in it. If we'll add crystalline water in it, if it's a crystalline salt or it's a hydrated salt, so hydrated salt is with water in it. For example, Na2CO3 is anhydrous. Now we'll talk about its hydrated salt or hydrous state. It's Na2CO3 dot 10H2O. Okay, so that's the formula. To find out the molecular mass of the crystalline solids, of the crystalline salts or hydrated salts, what we need to do, we need to follow the same procedure. We need to keep them separate. Instead of mixing them together, we need to keep them separate. Na2CO3 and 10H2O. So Na2CO3, so molecular mass of crystalline salt Na2CO3 dot 10H2O will be molecular mass of Na2CO3 plus 10. Let me put it a little bit side. Yeah, plus 10 MrH2O. Now, you see a dot between Na2CO3 and water molecules. We are not going to multiply it. The relative molecular mass is the sum or the weighted average. Like we need to add them together. Follow the definition. We are not going to multiply it, as a lot of students get confused. They multiply it, which is wrong. We are not going to multiply. We'll just multiply the relative atomic mass with the number of atoms present in the molecule. Okay, so here it's like, we're going to add them together. We already calculated Na2CO3 molecular mass, which is 106. And what we need to do, we need to calculate the mass of 10 water molecules in it. So it's 10, and we apply the same definition, the relative molecular mass definition, to calculate the molecular mass of H2O. So there are 2 hydrogens plus 1 oxygen, and 106 plus 10, and 2 hydrogen is 1 plus oxygen is 16. So it's like 106 plus 10 times 18. So it's 106 plus 180. 6, 8 and 280 gram per mole if you just calculate the molecular mass. Okay, so that's how we calculate the molecular mass of hydrated salt, or the crystalline, or the molecules, or the crystalline molecules, or the salt with crystalline water in it. Now make sure, don't get confused, just add them together, calculate the relative molecular mass of the salt molecule, and then separately calculate the molecular mass of water, and then add them together. You can do that. It makes things easy. Another example is CuSO4 dot 5H2O. So we calculate the molecular mass Mr CuSO4 dot 5H2O. Again, we are going to treat them separately to calculate it, and then in the end we are going to add them, or we add them together. So Mr CuSO4 plus 5 MrH2O, and here is copper, so we're going to do it like copper 1, sulfur 1 plus 4 oxygen plus 5 2 hydrogen plus 1 oxygen. Copper is 63.5, sulfur is 32, 4 times 16, and then plus 5, 2 times 1 plus 16. Add them together, so 16 like 0.5, 5, 95.5 plus 64 plus 5 times 18, so 0.5 and 9, 159.5 plus 90, and then you add them together. When you add them together, It's 0.5942, 249.5. So that's the relative molecular mass of copper sulfate crystals. And molecular mass of copper sulfate crystals is 249.5 gram per mole. So that's how we calculate the molecular mass of crystals. Calculating molecular mass of covalent compounds is simple, very simple. It is tricky when it comes to calculate the molecular mass of double salts or crystalline molecules. Rest is simple. For example, I'll take ethane gas C2H6. Sorry. So we'll calculate like C2H6. Again, first we need to identify the type of elements present in the molecule and then the atoms of each type of element. Okay, so there are 2 carbons, 6 hydrogens, and then 2 Ar carbon plus 6 Ar hydrogen, which is 2 times 12 plus 6 times 1. So it's 24 plus 6, 30. So that's the relative, this is the relative molecular mass for ethane molecule. Now, what's the molecular mass for ethane molecule? Molecular mass equals 30 gram per mole. So that's how we calculate the relative molecular mass using relative atomic mass. Thank you.